Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this session, we'll be showing you the new operation we've added called Inter-Operation Movement that we've introduced in SolidCAM 2011. What exactly is inter-operations movement? Let's look back a little in history as to how this used to work. If we were machining a part such as the one we see on our screen, we would have to do indexial machining, and we would first machine this surface over here, and then we would go to these holes on the side, machine those areas as well, and we would do this for every single one of those holes. Now, the movement in between these areas and this area, and as well this area to the next hole, would be on a 5-axis machine. It would go all the way up to the top to a safety area, then spin around to the proper position, and then come back down to the hole. But we've found that it will be more efficient if we can actually control this movement. So I can machine, say, this surface over here, and then go up only a certain amount and use a 5-axis simultaneous movement to get to these next areas. That's exactly what we do now in inter-operations movement, and let's see how this works. If we take a look at the operations we've done here, I've done a face mill for this area to machine off the top. After that, I've done a milling operation for these holes over here, as well as this hole over here, this hole over here, and last, this hole over here. So now what I've done to deal with the movement between each one of these is I've used what we call an inter-operation movement, as I've done over here. If I were to just show you the toolpath for a moment of the two operations with the inter-operation in between them, you can see that it went up and then just quickly spinned around on a very short path to get to this area. Let's take a look exactly what we have inside here. If I were to open this up, you'd see that we have just a data window, and we have our clearance area where we want to have our tool go up to, as shown over here. Now, in this particular case, we're working on a sphere, and the center point of the sphere is compared to my home position, as shown over here, is moved in the X, Y, and Z direction to get down towards the bottom over here. In other words, I moved it in this case to be at the center of the part. In addition, I said my radius that I want it to move on is 100 millimeters. Then I also have my angle steps for rapid move. That's the steps it actually takes as it's doing this rapid move, to move it in a rapid fashion. If I were to take a look at the toolpath, as you've seen over here, you see it looks very smooth. Now let's change it for a moment to something else. Let's change this to, say, 30 degrees. And then I'll do save. What you see here now is the new arc movement. And as you see, it's really not an arc movement. It's actually linear movement, so we can actually use a rapid movement to get to these areas. Change it back to 5, and you'll see that I have my radius movement again. Now, as you can see, I've actually done this not only here, but I've done this inside every single one of these. In other words, in between every single one of these operations, so that it can move swiftly between the different home positions. The operation itself is located over here. By clicking on it, it opens up the field, and I can add it wherever I want. Let's take a look now at the entire simulation of this part. As you can see, our first operation machines the very top of this part. Now, let me just slow this down, and I'll start running it through the next operations. As you see, the tool moves around to that area, switches around to each one of those areas, and as you saw, it just spinned itself around. We'll run it again, cleaning the top, arcing around to each one of these areas, and this is a lot more efficient for machining our parts. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.